So from this non-aqueous solutions, it's one of the important topic from inorganic chemistry. So I have collected a few questions from previous CSR exams and GATE exams. So we are going to solve those questions now. The first question is, which is the strongest acid among the following? So we have H2SO4, SbF5 and SbF5 and 2 moles of this compound, and SbF5 and 2 moles of hydrogen fluoride. So there are two acids we have, superacid and magic acid. Superacid means one equivalent of strong Lewis acid plus 2 equivalent of Bronsted acid, and magic acid means one equivalent of strong Lewis acid plus one equivalent of Bronsted acid. Okay, so superacids are very strong acids compared to the acids. So here we have two examples. So these two are the example for superacids. So we have SbF5 plus 2 equivalents of OH and SbF5 and 2 equivalents of HF. So among these two, the one which is having HF, hydrogen fluoride, that is more acidic. So 1 2, so second is more acidic than first. Okay, so only two superacids are there, so these are the two superacids. So among these two, this is the more acidic, so the answer will be fourth one is the answer. So next one we have, which is the strongest Lewis acid among the following. So here we have silicon fluoride, silicon chloride, silicon bromide and silicon iodide. So when we treat with silicon fluoride with 2 moles of F minus, it forms easily SiF6 minus 2. Okay, so in this case we have to see that electronegativity. Okay, so if you see the fluorine is there, fluorine is more electronegative, so because of that reason this compound will be highly Lewis acidic in nature. So the order will be SiF4, then SaCl4, then SaBr4, at last SiI4. So this is the order. So in this the answer will be SiF4. Next, BCH3 tries acting as a strong Lewis acid towards which of the following bases? So we know that BH3 is the Lewis acid, and we have a BCH3 thrice. So here the vacant orbital is there. So there are 4 options as given. We have a pyridine basis. In one pyridine we have electron withdrawing group, and in remaining pyridines we have a electron donating groups. Okay, so this is the acidic, and definitely this vacant orbital takes this lone pair. So the question is, which is the more favorable? So from the elimination method we can remove this because the electron withdrawing group is present on the pyridine. So the answer will be in these two, in these three. Okay, and which is more electron rich here? So this is a more electron rich, means this lone pair will be available for donation, but here we have to see steric crowding also. So this is the important here. So when we have a last option, in this case, so there is a steric crowding. So because of that steric crowding, so this boron can't approach this lone pairs that easily. So simply remember, so where steric crowding is there, that is the least basic towards the this one. So here steric crowding is there, here also steric crowding is there, but in this case there is no steric crowding because the methyl group isn't present at the fourth carbon. So the answer will be B. So this is the answer because here steric crowding is present. And a similar type of question, which is the strong Lewis base towards BCH3. Here also we have to see the steric crowding. So this is a highly bulky in nature, and here also bulkiness are means from this side bulkiness is decreasing. So this will be strong Lewis base and this will be least. Of course this is a like okay, just remember, so steric crowding is there. That means this lone pair can't approach to the this unvacant orbital that easily. Because of that, this is the least basic in nature and this will be strong Lewis base. And which of the following is a magic acid? I have said already, magic acid means one equivalent of Lewis acid plus one equivalent of Bronsted acid. Okay, so this is called magic acid. So here we have a one equivalent and two equivalent. This is the superacid, and this is also comes under superacids, and this one comes under the magic acid, and this also comes as a magic acid. Okay, so option 3 and option 4 both comes as a, both are examples for the magic acids. And the next question, we have a CaO plus SaO2 gives rise to calcium SiO3. So if you want to answer this question, CaO plus SaO2 gives rise to CaSaO3. So you must be knowing about the theory called Lux flood theory. So according to this theory, oxide donor is acid and oxide acceptor is base. So in the above reaction, they have asked in the above reaction which is act as an acid. So that is the question. So if you see here, there is a transfer of this oxide ion from calcium to silicon. We can see, we can divide this one calcium and SiO3 like this. So that means this oxide is going from CaO to SiO2. So here oxide donor is, this is the donor and this is the acceptor. Okay, so here calcium oxide is a acid because this is donating the oxide ion, and SiO2 act as a base because it is accepting the oxide ion. So the answer will be calcium O act as an acid here. And similarly we have PbO plus SO3 gives us PbSO4. Here also this oxide ion is transferring from PbO to SO3, and now this act as an acid because this is the oxide donor and this act as a base. This is the oxide ion acceptor. Okay, and then we have a few more questions. The treatment of ClF3 with SbF5 so leads to the formation of, they have given polymeric material, covalent cluster, ionic compound and Lewis acid base adduct. So this is very simple question. So here we have ClF3 plus SbF5 which leads to form SbF6 minus plus ClF2, sorry not plus. So this is the reaction. So here we can see that the fluoride ion is going from here to here. So this is acting as acid and this is acting as a base. So this forms a Lewis acid base adduct. So this is the Lewis acid base adduct. So option D is the correct answer. And the reaction of SbF5 with two equivalents of HF. H leads to form. So here we have SbF5 plus two equivalents of HF. So it leads to form SbF6 minus and H2F plus. So this is the product. Next we have consider the following reaction. So there are four reactions are given. So reactions which will give NO plus as a major product are, so in this reaction like we have in the first reaction NOCl plus SN, so it leads to form SnCl2 plus NO. So this is the first reaction. In the second reaction we have NOCl plus AgNO3 which forms AgCl plus N2O4. And the third reaction NOCl plus BrF3 which forms NO plus plus BrF4 minus, and NOCl plus SbCl5 which leads to form NO plus plus SbCl6 minus. Okay, so these are the four reactions they have given. This is A, B, C, D. So they have asked in the question which is giving a NO plus as a major product. So here we are getting NO, so this is not giving, and this is also not giving. Option C and option D is are giving, so the answer will be C and D. And here we have to remember one thing. So this kind of questions frequently they will be asking. So when we have a Br3 2 moles, so here we will get BrF2 plus and BrF4 minus. So the compounds which gives BrF4 minus, they act as a bases. The compound which forms this one, they act as a acids. And here NOCl is the base because it's producing the BrF4 minus. Okay, so on this equation one more question is there. Here the question is here, among Kf SnF4 SbF5 solute that increases the concentration of BrF4 minus in a BrF3 solution. So this is the question which I have discussed just now. So here the compounds which produces the BrF4 minus, we call them as a base, which produces the BrF2 plus, we call them as a acids. And here we have Kf, just remember SnF4 and SbF5. So these two compounds acts as acids in a BrF3 solution. That means these two produces SnF4 plus BrF3 which produces the SnF6 plus BrF2 plus. Okay, and SbF5 plus BrF3 which produces SbF6 minus plus BrF2 plus. So here we have one more example, that is Kf plus BrF3 which produces K plus and BrF4 minus. So in this reaction, from this reaction we can make out which is acid and which is base. The compound which produces the BrF4 minus, they are base. So here this is producing BrF4 minus, so this is a base. And the compound which is producing the BrF2 plus, they are acids, and these two are acids. Just remember Sn and Sb always in acid, they are acid in a BrF3. Okay, so the answer will be only Kf. They ask that which increases the concentration of BrF4 minus, means indirectly they ask which one produces the BrF4 minus. So that is the only Kf is the answer. And the next question here we have the compound which dissolves in a POCl3 to give a solution of highest chloride ion concentration is. Here also same, we have POCl3 So which produces the POCl2 plus, they are acids. So which produces Cl minus, they are bases. Okay, so this FeCl3 and SbCl5 plus POCl3, which produces the FeCl4 minus plus POCl2 plus, and similarly SbCl5 plus POCl3, which produces the SbCl6 minus plus POCl2 plus. Similarly, when you have KCl plus POCl3, which produces the Cl minus ion. Okay, so in these two cases we are getting a POCl2 plus. That means these two are acids. So when Cl minus ion concentration increases, if some compound which act as a base, okay, then only we can increase the Cl minus ion concentration. So in case of KCl, so Cl minus is producing. So here only in this case the Cl minus ion concentration is increasing. So whereas triethylamine is a weak base, it's not that strong, weak base. So we no need to take this one into consideration. This is a weak base, okay, this is strong base, and these are the acids, because when these two reacts with POCl3, so we are getting a POCl2 plus. So because of that reason these two are acids. And here we have about acidity, which is strongest acid here. So we have Fe plus 2. So by taking oxidation number we can identify. So this is plus 3 and this is plus 3. So since oxidation number is same, now we will go for the size. So based on size we can identify which is the correct answer. And here also same concept. Here we have A, B, C, D. We have 4 options. So this will be least acidic because this is the +1 oxidation state, and this will be more acidic. So D will be more, then A will be least. And what about these two? So here manganese is a +2 and nickel also +2. So as we go from the left to right, size will decreases. So the nickel will be having small size, manganese will be having a higher size. So smaller the size means higher the acidity. So this will be the correct answer. Then we have acidity order of boron trihalides. So this is one of the important question. So we know that BF3 we have BCl3, PBr3 and Bi3. So we have discussed one question, SiF4 is more Lewis acid than SaCl4, SaBr4 and SiI4. So here we can take about, here we can identify, here we can say this is more Lewis acid because of the electronegativity, but here we have to see the orbital overlapping. So this is the 2p orbital. 2p orbital of boron overlaps with the 2p orbital of the fluorine. And similarly, as we go from the fluorine to iodine, so what is happening here, the size of the orbital is increasing. So this is 5p orbital and this is the 2p orbital. So just remember that we know that pi to pi star overlapping and n to pi star overlapping. So this we have seen in the UV spectroscopy. So which is strong here? So this is strong because the orbital geometry is same. So because if orbital geometry is same, so we will getting a proper overlapping. So same thing here, when the orbitals are having same size, they will be having a strong overlapping. So when they are having strong overlapping, the electron density transfer takes place from this orbital to that orbital, okay, vice versa. So when we have a two different size, that time orbital overlapping is very weak. So because of that reason, in this case this is the strong Lewis acid. So this is the weak Lewis acid and this is the strong Lewis acid. So this is about some questions which I have collected from the previous CSR exams. I hope it's clear. If you have any doubts, you can write in the comment box. Thank you.